So in the meanwhile, as we have discussed in the last class, try out implementing the graph itself and then look into the traversal, either DFS or DFS. And in the meanwhile, I am getting some spanning trees, and you will help me to identify using Prim's algorithm based on the video which you might have looked into in lecture 5. Okay. So this is the task I am giving to you. Just look into this graph and come up with a solution. So give me the minimum spanning tree diagram. And after that, we will also go step by step on how we can solve this. So this type of question can also come into your theory exam. They might give you a diagram like this and ask you to draw a minimum spanning tree. So most probably the minimum spanning tree will be 1 and it matches with what you are doing, right? So all of your diagrams should match. So expecting that people have viewed the lecture 5 also, and I am going for this exercise. So I will give you 5 to 10 minutes of time, or 5 minutes maybe. Let's see who will come up first. Draw a minimum spanning tree for this graph. Okay, that's the task for you. And I will see how you can draw that. See, actually, we have, uh, you know, discussed on a algorithm called Prim's algorithm, right? To find the minimum spanning tree. I haven't discussed about crystals still. First, I am looking into Prim's. First, try to solve this one in a Prim's algorithmic way for a minimum spanning tree. Yes, anybody has answer for this?
Sir, doing it, sir.
Okay, okay, fine.
Sir, can I screenshot, sir?
Yes, you can. I'll stop it.
Sir, permission. Sir, is this the correct one, sir? Sir, is my screen visible?
Yes, the screen is visible. How come the B can be connected to D? According to Prince algorithm, I don't think that it can be connected to B, D.
Sir, the weight of B is less than the weight between A, B, no, sir.
No, no, no. What you have to think is that according to the Prince algorithm, you have to look into all the weights that are left. See, for example, you are coming from A to B, right? When you
Yes,
are
sir.
there at B, you should not only look from B's perspective. You should also look from A's perspective also if there is any edge that is left for A also. That's what in the Prince algorithm video I have discussed, right? What I told in that video,
Yes, sir.
you have to look to the previous nodes also which you have just bypassed or visited and see if any
Yes, sir.
edge
Leftover notes also.
and compare with those edges. I think if you compare that, I have given A to D as 9 weight, right?
Yes,
Then that
sir.
should be considered, not B to D, because B to D is 10. When compared to A to D, B to D is having larger weight, and B to F is also having larger weight, and hence I will go for A to D. Did you understand?
Yes, sir. Got it.
Yeah. So I will now explain that one and then give you another exercise for that. Okay. You see here. We are visiting this node, right? So I will say I am visiting this A as a node, and I am having a connection. From this, I will see what are the edges that are there for A. The edges are 14, 9, and 1. Which one is minimum? Which one is minimum?
1.
1, sir.
1. And hence I will connect the edge that is 1. Right, finished. And now I am at B. From B, I will see that 1 is already satisfied. I will not only see from B the 10 and 15, but remember that I have to look into the leftover edges. What are the edges that I have left over? From A, I need to check that I am having 14, 9, and from B I am having 10, 15. That's what I said in the last video, in the lecture 5. That A should be also considered, not only from B, I should also consider if there is any minimum edge that I am leaving behind. As which is minimum? 9. So I need to consider only the edge 9 when you compare between 14, 9, 10 and 15. So I will go for this edge connecting to D, which is 9. And now tell me from D what you want to see. What are the things that you will check now?
Sir, 14, 10, 15, and 2 and 11.
Yes, so let me draw some other lines like, okay, let me draw first these nodes C, G, F. Okay, so I will put a dot mark. So you have a dot mark telling this is 14. This is a dot mark 2. This is a dot mark 10. This is a dot mark 15. Okay, and this, let us slowly fill if anything that we want still to get filled. So first I am filling with the dots. Okay. So now among this, I need to consider, now tell me, what are the things I need to consider?
Sir, 14, 10,
14,
and 2.
10, 15,
15,
2 and 11.
2. Yes, sir.
Minimum, 2 is minimum. Hence, I will connect these two.
C and D.
C and D will be connected. Right? Right. Now I am at C. What are the things now I need to look into?
Sir, 9,
Yes.
14, 10,
Not,
and 2.
not 9. 9 is already finished.
Oh, yes, sir.
Now tell me. What are the things that are left over and I need to look into? Yeah. 14,
14.
10, 15, 11, 9. Yes?
Yes, sir.
Right? So 14 is left from A, 10 and 15 left from B, 11 left from D, and 9 left from C. Among this, 9 should be your thing, right? So this is the minimum. So I will select this one. So I will draw right here. So here we have 6, right? Still. Now tell me, what are the things that are next left?
14.
Sir, you forgot to give the edge of G and F, sir.
Yeah, that's what I am thinking about. Yes, yeah, this is 6, of course. Now, what are the things I need to compare now? Still, again,
14,
6.
14,
10,
10, 15,
15,
11,
11,
and 6.
6.
So 6 is minimum, and hence
Join GF, sir.
consider 6. Join GF. So this is your final spanning tree. Then you might ask me, sir, why can't we consider if we come to F? We have again 14, 10, 11 and 15, so we got 10. Now remember, one of the very important property of minimum spanning tree is you should not, sorry, form a cycle. So if you are trying to fill this one, then this forms a cycle. If you're trying to fill this one, then this also forms a cycle. So remember, if you are at a position where anything that you are trying to fill is forming a cycle, then you have to stop there itself. So this is your minimum spanning tree. And minimum spanning trees never consist of cycle. So the graph which is set as minimum spanning tree will never consider a cycle. Why we need cycle? Because we already had a route of approach from B I can reach A, from A to D, D to C, C to G and E to F. So finally I have reached all the nodes. Why should I need a cycle now? If I make it this one also, what is the use for me? Or this one, what is the use for me? Just to go to D, I can go to A and D. Why I need to go to directly this one? So this is actually considered minimum. So even I go to this one, I have the same kilometer. For example, you take these as kilometers. So this is 10, 1 and 9 also 10. If I need to go to, see, you might ask me, sir, why can't we consider this 11? But the spanning tree is not about the shortest distance, right? So definitely we should go with the edge with a minimum weight. That is more important in the minimum spanning tree. So I am only choosing the path of minimum weight when considering the others. So this is a minimum spanning tree. Okay. So I will give you the next one. So this is the one. Try to solve this.
Hello, sir.
Yes.
I had doubts, sir, in previous question. Can you show? Yeah, show that, sir.
Tell me.
Sir, here B2D, if suppose it is 9, sir, what will be the answer, sir?
B2D is 9. Okay. So among these two, you can consider B2D directly. 9. You don't consider A to D, because when these both are equal, so at what current position you are, that should be considered. Okay.
Okay, sir.
Yeah. Now your doubt will be clarified here when you do that. So you can take anything. So some people might take this path also. Okay, among these things, you might prefer that this path is good or this path is good. I think in the video I have told you, when we have two things, maybe we can take that one, but it should not form a cycle. You can say that, sir, why can't I take these two? But this forms a cycle. So any one thing you have to choose. So for that choosing, you can take either this path or this path, but most preferably, if you are at B, try to choose this path. That's what I suggest. So the basic application of the planning tree will be with networking. So to reduce the number of hops and to choose the short, very less weighted path, people will actually design the network using minimum spanning trees. Even they design the protocols to route the packets like that.
Sir, you didn't
Yeah,
given the
somebody is asking a doubt. Any doubt?
4 to 5, you didn't given weighted, sir.
Hello?
From edge of 4 to 5, sir. You didn't given any numbers, sir.
Edge, yeah. Edge 4 to 5. I forgot to write something. Yes. So if we take a number which can maybe just look into this. I want to write something which can help you to do a little bit. Okay.
Sir, is it the path between 0, 1, 4, 8, 5, 2, 3, sir?
What you said? 0, 1?
0, 1, 4, 8, 5, 2, 3.
0, 1, 4. After 4, why did you choose 5?
No, sir, 5 not, sir, 8.
0, 1, 4, 8. Okay, next.
5, 2, 3.
Okay, 5, 2. Okay, 2, 3. Okay, from 5, you are connecting from 2 and 3. Next, you still there are other nodes like 6 and 7 are still remaining.
If we include them, it is forming a cycle, no, sir.
Hmm.
Sir, can you
No,
share my
that
screen?
will not give any cycle, right? Because I am not connecting between 8 and 6. There is no connection anyway
Okay, sir.
because we are missing 6 and 7. Just look into it carefully.
Sir, can I share my screen? Sir, is it visible? Hello, sir.
Yeah, I'm talking, but I am on mute. Yeah, it is good, but one mistake is there. I have given the weight from 1 to 2 is 9 and 2 to 4, 1 to 4 is 8. How did you choose 1 to 2? Did you understand what I said?
Yes, sir. You corrected, sir.
Okay, so let me share the screen and yeah, thank you for that. And it is also good one. You have almost conquered it, but a little bit of mistake that you could not see. Okay, let us see. When you are at 0, when you are at 0th node, compare 10 and 11. Which path I need to go?
10, sir.
10. So I will fill up with 10. Right. Next, when I am at 1, I will compare the leftover 11, 9 and 8. So these are the edges that are there in my disposal. So 11 from 0, 9 and 8. Which one is minimum?
8.
8, sir.
8. So I will choose this path. Right. Okay. From 4, we have at our disposal 11, the last ones, right, 9, and then 4, 7, 10, 5, 8. Which one should I go?
5.
Okay, so 5. Right. So we got 5. Now at 8, we have some disposal. We have something like 11, which are still remaining. The path that we have covered. From one side, we have 9. From 4 side, we have 8. Still 7 is there, right? 7, 10, these are there. And also from 8, we have 6 and 11. Which one is minimum?
6, sir.
6.
6. So we go with this path. Carefully observe what are the things that you have left. Now we are at 5 now. The same thing. So we got 11. Don't consider from 3 because you only need to consider the path that you have come up to now and what are the leftovers. Here we got 11. And from one side it is 9. From 4 side it is 8, 7, 10. From 8 side it is 11. From 5 side 1, 2, 10 are there. Which one is minimum?
1.
Okay, so 1 is minimum and hence we come to this. And because now it is the end, we cannot form anything because it might form a cycle. Because see, if you fill this one also, you have a cycle, right? So come back to 5 again. And from this, what is the minimum side that we have left over still?
2, sir.
2. So I choose 2. Okay?
Sir,
Yes, tell me.
Sir, after going to 2, can we directly connect it to 3, no, sir?
No, any path I can take. Any path I can take. Yeah, you can take this path or this path. Anything is correct.
Okay, sir.
But see, I came back because I want to still go to 4 again. Okay. From 4, what are the remaining things based on the comparison that you have left over?
6 for 2, 6, 8 and 2, sir.
8.
Sir, after 5, how you went to 4, sir?
That is not a path. It's not a rail engine to go through the path. So we are looking into what are the things that we are still left with. See why we are coming. So when we are coming to 8, I am just telling that because we are at 8, I want to go to this one. Maybe I can go to 7 also and check what are the things that are remaining. And based on that, I can have a connection. So I am just going in this. I see that already 0, 1 are visited. Maybe I can connect this one so I can come to 3. And after 3, anyway, I have to come back, right? At any point, I have to come back, or 5 or something. That's why I have given this type of graph. This is not so easy to understand, right? So, but still you can go back to 4. And from 4, what are the things that are left here?
10 and 8, sir.
Yeah, otherwise you can also go to 6 because 0, 2, 1, 3, 5, 4 are all visited. You can also go to 6 and you can see that the remaining thing that you have among these is the lowest value 8. Because among 11, 9, this again forms a cycle. See, if I connect this one, this forms a cycle, you see. That's why I eliminate this one. So remember, do not form any cycle. Without cycle, you can get all the minimum edges. So you can 8. What is the leftover thing without forming a cycle that I can connect?
6 to 7, sir.
Yes,
7,
6 to 7. That's all. This is your minimum spanning tree that you got. So every time what you are doing using Prim's algorithm, actually you are checking with all the leftover ones. Like the leftover ones are 11, 9, 2, 7, 10, and 11 with the latest value that you want. So sometimes you might ask me, sir, because 2 is the minimum value, why can't I choose this? But if you choose this, you see it's forming a cycle. You should eliminate either of these because they are twins having the same weight. Okay, you can already reach 3. Why should you actually go for that? So I can choose this path or this path and I eliminate the other one. See, at any point, I should not form a cycle. Without forming a cycle, I should choose the minimum value. See, if you consider this 8 and 7, you say that sir, 7 is minimum, but it forms a cycle. So eliminate this one and come to the next minimum, that is 8, and connect them. And then next connect 2 without forming a cycle. Now you cannot connect this one because this again forms a cycle. See, finally what is the final graph? So this is the one, this one, this one, this. So this is your final graph that you had. Okay, this is the minimum spanning tree. So wherever you see there is no cycle, that's what you need to remember. So I will just rub up these things so that you can visualize what happens here. Yes.
It's 3 o'clock.
Okay, so this is the spanning tree that we got. Right, I hope you understand the first thing and foremost thing that you have to remember is you should not form a cycle in the minimum spanning tree and always eliminate the twins if it's forming a cycle, otherwise you can select if it is not forming a cycle. After eliminating, if it's the minimum value, go to the next minimum value and connect it. So that's how you can go randomly. There is no need that you have to only go through one after the other. But see that it is a minimum spanning tree, right? I will give you few more exercises tomorrow also, then you can come up with a solution more easily. So bye bye for today.